time. Hi, welcome to the reading group is what we're doing today. And we're going to be reading this, which is a blog post. The blog post is Commonsense Reasoning for Natural Language Processing by Vered Schwartz. And I'm going to just double check that that is, in fact, what the title is. I'm pretty sure. Yeah. And it was based on a tutorial from ACL 2020. So ACL is a conference for the Association of Computational Linguistics. And the tutorials usually happen right before the conference, and you learn about something. I don't know. This is a way to keep, like, if you're a grad student in a school that doesn't offer a lot of course material in a particular subject, a way to learn about that. Or if you're wanting to continue your professional education in research or get into a new research area, it'll help with that as well. So those are what tutorials are. And this one was taught by Maarten Sap, Antoine Bosselut, Yejin Choi, Dan Roth, and Vered at ACL 2020. So, and hopefully everyone can hear me. I turned off one of the audios, and I think it's the one that was causing the echo and not the one that was causing me to be understood, but we'll find out, I guess. Anyway, we read through most of, well, I'd say a little over half of this last week. And we can quickly review what we've already gone over, and then, hi Robbie, talk about the rest of the blog post. So, yeah, common sense is, insert any number of silly jokes here, but common sense is a name for sort of the ability of a system to understand and reflect, hi Omar, the world around you. So some examples here of systems doing common sense poorly. With object recognition, these both look like pandas to me, but with a pixel mask, you can create an adversarial example where the system recognizes it as a different animal. In dialogue systems, the person saying, "How are you?" and the assistant replying, "I don't know." So not understanding the meaning of the utterance or reacting in an appropriate way. Visual question answering, how many zebras are in this image? The answer is 2. There's more than 2. For open-ended generation, a lot of repetition. For image captioning, factually incorrect images. And then for question answering, answering the question correctly. So we're not there yet, basically. We don't have good common sense reasoning with natural language processing systems. And there are some things that we can do pretty good. So actually it might make sense to talk about like different types of common sense as well. And I know I'm in front of it. I don't know. Unfortunately, the way that this blog is set up, I can't zoom in more without having to scroll with every line. So this is as big as it gets, and it means that I'm in front of the text, and I'm sorry about that. So social common sense, knowing about people and what people are likely to know, and their emotional state and that sort of things. Temporal common sense, so knowing that X has to happen before Y, being able to understand how information conveyed using tense and aspects, which are the ways that language encode information about time and duration of events, and being able to map that onto some sort of model of things occurring in time. And then physical common sense, understanding how physical objects act in the world. I was gonna say in the water. Nah, in the world. Does it even say water in here? Yeah, I don't know where I got water from. Probably from like the walk from here and the tur from Shatter. More coffee. Ooh. Sorry. It's good coffee. So I think there's been a lot of sort of discussion and there are certainly people who will sell you the idea that we've already got there with common sense knowledge, just by having really large language models, and that they've, distilled all of the human knowledge that's on the web. And I think that that is like verifiably false, and also is a very, narrow interpretation of what human knowledge is, and apparently it's all contained in English. So there are some things that pre-trained language models can do. Sorry, I'm being very, very, very sassy today for some reason. So filling in the blank, that's literally what masked language models are trained to do. They're pretty good at it, and they can fill in the blank in ways that are sometimes make sense. They can associate concepts with their properties. So again, they sort of know about words that tend to get used together a lot, just like any sort of vector semantic or word vector representation. So they're pretty good at associating, bear with the properties of bears, because they're written about a lot. But some pretty big problems with language models that shows that they're not capturing this common sense reasoning. So they are not sensitive to negation. So in this example, birds can fly and birds can't fly are ranked as being, equally possible. And I think a better example might be something like humans can breathe air and humans can't breathe. Well, I'm trying to think of an example where, because there are some birds that can't fly, but it is sort of a property of the class of birds that most of them can. I'm trying to come up with a really good example of something where it's clearly unambiguously wrong in the negation every time. Like humans are bipedal, some people aren't, and that's, just normal variation. But anyway, I guess like a good example would be like, I can fly and I can't fly. Like I can't fly, right? I'm a human. I don't have wings. I cannot fly in the air under my own power. Would be ranked as similarly possible. Ostrich, yeah. No, there's definitely birds that can't fly. Anyway, but these models aren't as sensitive to negation. They aren't sensitive to the semantic relationships that I think anyone using language would be. They're also sensitive to phrasing. So a semantically equivalent. So here the example is the sky is blank today, as opposed to today the sky is blank. So these should have similar ways to fill them in. So these are semantically equivalent sentences with blanks, right? The meaning of them both is the same, but the surface syntactic structure is different, and that shouldn't affect the underlying meaning, and yet here it does. And also we have this sort of overgeneralization. So this example is the color of the dove was blank. Doves are small birds. They're usually gray or white. Pigeons are a type of dove. And here the most likely way to fill that in is red. There may be some red doves, but it is not the most canonical color of doves. Anyway, so just some ways in which the large language models do not capture common sense reasoning. And also they have the black swan problem, which I think we talked about a little bit further down. Hi, Shiva. Is that people are more likely to talk about and write down things that are rare as opposed to things that are common. So any sort of model learning just from text is going to learn some things that are, not well represented in the world, right? So like, I've probably in my life said I have a headache more often than I've said I don't have a headache, and yet most of the time I don't have a headache, right? Or people are more likely to remark on the color of a swan when the swan is black. This is the canonical example everybody talks about, than the color of a swan when a swan is white, because most swans are white. Originally an example was for something that doesn't exist, but actually, as it turns out, the person who was writing that did not know that black swans are very much a thing that exists in the world. Anyway, and then we talked about a lot of different, good coffee. And then we talked about a lot of different tasks and some ways to measure common sense reasoning. And a lot of the current tasks are multiple choice questions, basically, which I think it's like evaluation is hard, right? Evaluating systems, especially generative systems, is extremely difficult. A lot of the, and this is also something that was talked about in the blog post, a lot of the sort of automated measures that we have at best sort of a loose correlation with human ratings. So, but a lot of the current tasks have these sort of multiple choice ways of capturing reasoning. And then there are a lot of different, oh, and this is something else we talked about. I'm just scrolling through here and like refreshing my memory because it's been a week, y'all. It's been definitely a week. There's another big problem with these sort of, you know, using a language model to do things that the language model wasn't trained for, is that often they are relying on spurious statistical cues in the text. So like a word that they've seen before in a certain context that will not always appear in that context, but it is just that it happened to appear in the training data and now it's appearing in the testing data and the model has picked that up. And that's not, you know, a very generalizable model, and the fact that it is able to pick up a statistical cue does not mean that it has a good extensible, you know, ability to handle novel situations, if that makes sense. Question, looking to build a chat bot. Which parses a Word document. So I would, you're probably going to have to build something else around the Word document, regardless of what chatbot framework you use. Some sort of, you know, document retrieval thing or knowledge extraction is another good set of keywords to look at. You definitely have options, but I don't think, to my knowledge, none of the major chatbot frameworks are going to do that as part of the chatbot, because it's a slightly different task, right? So. Yeah. So Robbie's asking about, I would call that pragmatics. So this is a situation where, like if I say, oh, it's chilly in here and the windows are open and it's cold outside, what I am asking you to do the first time saying that it's chilly to you is close the windows, please, because I'm cold. And sort of that understanding of something that is not reflected in the formal semantics of the word, but is understood from the social context in which they're said, is pragmatics is what I would call that. And I would say common sense. I think people who are working on that task would usually call it more pragmatics and less common sense, but according to this definition, I think, because social common sense was one of the bullet points, I think it would fall under here. Yeah, I don't know if automating pragmatics would be considered common sense or not. It feels common sensey, but I would be surprised if the literature calls it common sense, is where I am on that. But again, it's not an area I've done a whole bunch of reading in. Yeah, no worries. Anarud? That's my guess. Sorry if I'm saying that incorrectly. All right. So, and then the last section that we read last time was how do we gather and represent machine readable common sense knowledge. So there's a bunch of sort of approaches here. Historically, I mean, this is something that's, you know, you see the oldest paper here is from the 80s, and this is something historically that's been done by expert annotation and, you know, linguists developing a framework for representing this, and then, you know, annotating the semantics of stuff by hands. Lots of grad student hours went into these projects is what I'm trying to say here. And probably a fair number of undergrad hours as well. And because like writing this sort of looking at you know, plain text and then writing this sort of structured representation of the information in that text, you know, takes some training. And different types of things, ConceptNet, and then also there's been some work on trying to automate the extraction, and I think there's also been some work on crowdsourcing to create these sort of knowledge representations. But yeah, so using, you know, creating a data set like this is extremely time intensive, and I think the majority, if not all of these, have been in English, which is another enormous limitation. Because, of course, the majority of people on Earth do not speak English. And I do speak English, perhaps, obviously. But I recognize that my experiences are not universal. Oh, well, thank you. Pragmatic, sorry. So the thing where it's pragmatic, pragmatic, and pragmatics. So syntax is the structure of, you know, the study of the structure of sentences usually is the unit that they work over. And semantics is the formal study of meaning as it's represented in language, and pragmatics is the study of the meaning that is not in the text itself, but can be inferred from the larger social context. Hopefully that helps. Linguistics vocabulary. Psycorp. Oh, so I'm guessing that this is sort of the knowledge extraction thing. Yeah, it's not my core area. All right, so let's hop back into reading the blog post now that we have summarized it. It took a while to summarize it, but this is a very rich blog post. It's you know, covers a lot of ground. All right, how to enhance neural models for common sense reasoning tasks with symbolic knowledge. Most models developed for solving common sense benchmarks today are based on language models. Typically, each answer choice, along with the context, forms a statement. The language model computes a vector representing each statement. The vectors are then fed into a classifier that assigns a plausibility score for each candidate answer, which is probably based on, I think this was mentioned further up, but it's probably based on the overall probability of the statement, using something like perplexity. Sorry, I kept like, my mind was like entropy. I was like, it's not entropy, it's the other one, perplexity, which is a measure that language models, I think it's also like a language model level measure, but it's also something that you can give to a string. And symbolic knowledge is like the stuff where it's represented with structure. Static neurosymbolic integration. Oh, and here's an example. Katrina had the financial means to afford a new car, while Monica did not, since, and this is the second thing, Katrina had a high-paying job. Same sentence, Monica had a high-paying job. It's probably Katrina that has the high-paying job because she can afford a new car, and the probability was assigned to each of those. And this is a Wino Grand instance. The knowledge in common sense resources may enhance models built for solving common sense benchmarks. Sorry, I read that. I didn't understand any of it. The knowledge in common sense resources may enhance models built for solving common sense benchmarks. Okay, so we can use these hand-built data sets or hand-built structures of meaning for a language, English, to enhance these neural models. For example, we can extract from ConceptNet the assertions that job is used for making money, that spending money requires making money, that buying requires spending money, and that car is something you can buy. So it connects these things. Ideally, we would also need the knowledge that a high-paying job is a type of job, specifically one used for making a lot of money, which is required for spending a lot of money, which is required for buying something that costs a lot of money, car being one of them. Finally, we want to remove the edge from buy to car, so we only get to the car node. So we can only get to car from the node buy something that costs a lot of money. So this is a graph structure And most of the sort of like structured knowledge databases are represented using graphs where the nodes are entities and the edges indicate some sort of relationship. So here what they're saying is these relationships, that a high-paying job is a type of job, that making money entails make a lot of money. If you have made a lot of money, then it is true that you have made some money. If you spend a lot of money, then it is true that you have spent some money. So this is like entailment of degree. Oh wow, I'm brushing up some of my my semantics grad courses. So this knowledge, like the fact that these nodes have these edges, would be looked up in the database, and then you would remove the knowledge that would let you get to, you remove the nodes that would allow you to get to car except for one path. So you make it a, yeah, it is directed. Sorry, that squinting was me looking for little arrows. So you make it a directed acyclic graph, because if you have these here, then it is cyclic, so you can get to the same node multiple ways. So that you can step through this and create a single sort of path through the understanding. Is the general idea. So once you've done that, how do we add it to a neural model once we have this sense of understanding? The simple recipe, success not guaranteed, calls for 4 ingredients: the task address, the knowledge resource used, the neural component, and the combination method. We have already discussed tasks and knowledge resources. So tasks are these multiple choice questions. There's a data sets. There's a bunch of different ones. The resources are these ones that we talked about in sort of medium depth. I think they're probably going to use ConceptNet. The neural component is what sort of deep learning model are you using, and then the combination method is how are you going to stick these Lego pieces together. Well, I guess they're not Legos, because Legos you can only stick together in a limited number of ways. Actually, no. I think the Lego analogy is a good thing, because the dimensions of the data in and out are extremely important. So, yeah, how you can stick these Lego pieces together. I will only add here that ConceptNet is the main resource utilized for downstream models, although some models incorporate other knowledge sources, such as other knowledge bases, WordNet and Atomic, knowledge mined from text, and tools, knowledge base embeddings, sentiment analysis models, and Comet, see below. And I'm going to look up something really quick, because it's a question that I have. Is ConceptNet the one out of Berkeley? So there's this enormous project out of Berkeley that a bajillion people have been working on for ages, and I want to know if it is, in fact, ConceptNet, but I cannot remember off the top of my head. Let's see. Concept here. Let me pop this over so y'all can see what I'm looking at. So this is sort of the information for ConceptNet. Last release was in May of this year. Additional data sources. I guess let's explore ConceptNet. Semantic network, freely available. No, this is out of MIT. Okay, so this is not the thing I was thinking about. What was I thinking about? I was thinking about like the big data set that has a lot of stuff on different containers, which is this semantic concept. Anyway, there's semantic formal frameworks have historically differed quite a bit between different research groups, and sort of like what I was going to say, and the specific thing that the specific framework that you're using matters quite a bit. I said it was only in English. I think I'm wrong. I'm seeing French. I'm seeing Dutch. I'm seeing Spanish. I'm seeing Portuguese, and I'm seeing Japanese. All right. Okay, so ConceptNet is used to create word embeddings. Here's an example of a ConceptNet. As you can see, it's a directed graph. Open data, fantastic. Sources of knowledge, they've got a bunch of different stuff in here. attribution. It's part of Luminoso Technologies, MIT, and now type around the world, led by Robin Spear with contributions from other people, so it's open source. Okay. I was like, I haven't worked a whole bunch with knowledge bases before, so this is it's one of those things that like I know about, but I have not really done a whole bunch in Arabic. Okay. Catalan. I was gonna be like Canada. No, that can't be right. Okay, we got looks like Greek. Oh yeah. Azerbaijani. Okay, yeah. So we actually have a pretty good representation of different languages, even if it is pretty Eurocentric. Nice. Yeah, we've got Arabic. Does it say? I guess if it's written, it doesn't matter the dialect a whole bunch, right? Because most Arabic dialects are use the same writing system. Estonian? Esperanto. Well, noted. Icelandic, Greek, Frisian? What's FY? Western Frisian. Frisian is the language that is most closely related to English, by the way. Well, depends on how you feel about Scots. STQ. Soderland Frisian. Okay, so different places. Sanskrit. Great. Good to have Sanskrit. Do y'all got... Tell me this is not Old English. It's Old English. Is this Middle English? That's Middle English. Okay, well... Oh, you can't see. It's not picking it up. But when I mouse over the little ISO tags here, I'm getting the name. What's this one? Vola? Volapu with an umlaut K. That feels like it might be a dead language. If it is a very widely spoken language, I apologize. IDO. Also don't know that language. Turkish, English, French, and German. Interesting. Okay, so I take it back about it being in English. Which is nice. And I mean, in theory, right? Concepts should remain fairly static across languages. I'm not getting into a discussion of linguistic relativism here. You can go hit up Dan Everett if you want to get into that, which I don't especially. Sorry, I'm trying to see if I can get a list of languages that they use. Are we off topic? No, because they're talking about this, so I think it counts. 34 million statements. Does not use logical predicates. Helpful. Formal logic. A lot of semantic systems use formal logic. It is not something I know very much about how well it fits in with actual usage and sort of things. I am still looking for the list of languages, and I don't have it. Anyway, so it looks like you can use this for projects that aren't in English. You might need to do some more finagling. Yeah. Sanskrit is a scientific language. Yeah. Like, I guess it's sort of like Latin, right? Like, there's been a lot of use over time in different contexts, but I don't know that anyone speaks Sanskrit as their first language anymore, right? I don't know. This is a tangent. I've been thinking a lot about the idea of dead languages and the way that it sometimes, like, it gets applied to indigenous communities a lot in a way that I don't like. sleeping languages is a term that I've heard that I like a little bit better. But I like, no one's being persecuted for speaking Sanskrit that I know about. I will put it this way. No one's being persecuted for speaking Latin that I know about. I think they have a lot of similarities. Anyway, also fun fact, the oldest linguistics texts are written in Sanskrit. Anyway, back onto topic. Let's go. Okay. So you're talking about blah blah blah. They're using ConceptNet, which we now know a lot more about. Is the main resource utilized for downstream models, although some models incorporate other knowledge sources, such as other knowledge bases, WordNet Atomic, blah blah blah. We read all that. Resources used by most knowledge-informed common sense models. WordNet, CYC, Atomic, mining from corpora, handcrafted rules, specialized embedding, sentiment analyzer, comment, but this guy's like, ooh, ConceptNet. The neural component is the shiny new neural architecture, language models in the last 3 years, bidirectional LSTMs with attention in the years prior, etc. This is definitely like, you know, it's a cycle in the NLP research community that a new model is introduced. A lot of people get really excited about it. Something else is introduced. More people get excited about that. And I mean, this has been going on since what, the 60s? The more interesting component is the combination method. We will look at 3 examples. So they're saying we're just going to use like a vanilla version of whatever this is. Incorporating the scoring function. Sanskrit, the language of ancient Indians. His D is derived from Sanskrit. Yeah. Like you know, sort of like Spanish or French or Italian are derived from Latin. But I don't know. I feel like resources in Sanskrit and Latin are not the deepest need that any language community has right now. I would prefer, you know, resources in more. Have I just been dribbling coffee on myself the whole time? It's not in screen. You can't see it. Just know that I'm apparently covered in coffee. Incorporating into the scoring function. Lin et al. 2017 extract probabilistic rules connecting pairs of terms from multiple sources such as WordNet, restaurant, eatery, one. So restaurants and eateries are basically the same thing. Wikipedia categories, restaurants and businesses, all restaurants are businesses. Script knowledge mined from X. X went to a restaurant implies X to 8, 0.32. So it is, you know, this is not, it is probable that if you go to a restaurant, you eat, but not always. Word embeddings related to score, so restaurant food, high score, and more. The model scores each candidate answer according to the scores of the inference rules used to get the context. E.g., Mary walked to a restaurant in figure 14 to the candidate answer, she ordered food. Okay, so I see. So there's a term relationship that restaurant and ordered and foods has, and then there's a relationship between slept and walked to has, and the green here, the green solid ones are co-reference. So this is where a word refers to the same concept. 2 words refer to the same concept. This sort of that here is narrative that these things are likely to occur together in some order. I don't know where they're getting the narrative stuff. Script knowledge, mined from text. I wonder if this is from like scripts potentially. I'm not entirely sure what they mean by script knowledge here. And then associative, that restaurant and foods have an association with each other, and that's the dit, or I don't know, that doesn't really look like Morse code, the dashed line. Representing symbolic knowledge as vectors. Lin et al. 2018. Lin's a very common name. I was gonna be like, I wonder if these are the same Lins. I don't really want to scroll down. I'm gonna go with probably, but maybe not. Used BERT as the neural component to represent the instance statement vector. For their symbolic component, they extracted subgraphs from ConceptNet pertaining to concepts mentioned in the instance and learned to represent them as a vector, graph vector. The 2 vectors were provided as the input to the answer score, which was trained to predict the correct answer choice. Okay, so they're using BERT to represent the statement vector. Okay, so just stick this through BERT, get the numbers out. And then they extract subgraphs. And the subgraphs were provided as an input to the answer scorer. I'm not entirely sure how these are connected to each other, right? So I guess my question is here, you have this symbolic component, right? Oh, I see. Okay, so the two vectors that you use are you use the vector that comes from the input that you get from BERT, and also a vector representation of this graph, because you can represent graphs using a flat vector representation like this. So there is structure here, and it is hierarchical structure, but it is represented as a flat string rather than like a JSON file. You can just like look at it as a sequence of characters, but also it represents a structure that has hierarchical structure within it, that sort of thing. Okay, that makes sense. And then in 2019, so same year as this previous paper, Xia et al. Fine-tuned a BERT model to solve multiple choice questions. They also trained 2 auxiliary tasks supervised by ConceptNet, in which 2 concepts were given as input, and the classifier had to predict whether they are related or not. Excuse me. And the specific ConceptNet property that connects them. Okay, so they're using not multitask learning, not federated learning. What's the word I'm looking for? Not concurrent learning. Anyway, it's the approach of machine learning where you train multiple models, but you only really care about the input of you train a model to do multiple things, but you only really care about one of the things. As opposed to multitask learning where you care about both of the things. Geomini cricket, I can't remember the term. Anyway, the idea is that because you're doing a variety of tasks, your model should be able to generalize better and handle noise and etc. Prevent overfitting. And then so there are 2 auxiliary networks plus the main one that does the task they're interested in. One of the networks gets 2 concepts and has to predict whether they're related, and the other network has to predict what the relation is. Okay, so that's what this says. Multitask learning. Oh, maybe it is multitask learning. Oh, I feel like there's another term for this though, like I know it's not federated learning. I know federated learning is about distributing processing power to work on a single task, but I can't. Co-learning? No, that's not it. I don't remember what it is. Anyway. How it says, most of the subcontinent languages derived words from it. Yeah, like I'm not saying Sanskrit is not important. And I think it is good for anyone working with, languages to know about it. I don't know. I think that's what I'm trying to say. Yeah. And then the BERT model was shared between the main and auxiliary tasks so that Commonsense knowledge from ConceptNet was instilled into BERT, improving its performance on the main task. Because again, you don't care as much about the auxiliary tasks as you do about the main task. Tess says, if you direct graph neural network methods for NLP, any thoughts? I mean, these methods are working on graphs. They're working on the ConceptNet graph structure. Yeah, I think you're talking about something different though, in which case, no. All right, so this is one way of combining these things, and basically you just have sort of either you're doing some sort of rule extracting that you can use, or you're representing those relationships as a graph that you're using as input to your system, or you are using a graph to, train your model at the same time using multitask learning. I just can't remember what the term is. There's a specific term for it, and it's just not in the old bowl of oatmeal today. Dynamic neurosymbolic integration. There are 2 main limitations to the neurosymbolic integration discussed above. coverage. Relevant knowledge is often not found as is in common sense knowledge resources, which makes sense. Like the 34 million relations, which is what ConceptNet has, does not cover all of the relationships between things in the world and all of the sort of like qualities that objects have. As we've seen earlier, common sense knowledge is immeasurably vast, so much of it is not documented. Precision and context. Knowledge found in the knowledge base about context X does not necessarily apply to all contexts in which X appears. For example, when provided with person X adopts a cat, Atomic says that person X has to go to the shelter first, but that's not always the case. You could adopt a stray. Oh, that's what they say. It may as well be that person X adopted a cat they found on the street or got the cat from a friend who is no longer able to care for it. So here are all of the inferences for person X adopted a cat. The inference is that person X wanted company to help an animal need, to have companionship, to have a cat, to provide a home for a cat. Person X needed to go to a shelter, pick out a cat, to like cats, to go to the pet shelter, a car, a cage. I mean, you don't need a car to adopt a cat. I have a close friend that has a cat and no car. So a lot of these inferences are true in some situations, but not all. And these are also, I would say, very culturally bounded as well. Like, I'm sure there's places in the world where animal shelters are not a thing, and I just don't know about them to say where that might be. But, yeah. Oh, Quick 24 says it is pronounced psych, the CYC database that we've looked at a couple times. Thank you. I didn't want to pronounce it phonetically because it looks a little bit like a slur, and yeah. This one, psych. So psych, open psych, research psych, and then open psych 4.0. Very helpful. There we go. Yeah, anyway, so a lot of these sort of relationships are very culturally bounded. Attributed to person X is nurturing, caring, loving, is seen as nurturing, caring, loving, compassionate, seeking companionship and comforting. As a result, person X feels happy, proud, excited, loved, hopeful, proud of themselves, loved, depends on the cat. Tolerated perhaps might be in that. I quite like cats. As a result, person X wants to go home, feed the cat, take the cat home, take the cat to the vet, buy cat litter to feed it, to give it a name. Person X then grooms, pats, gets excited, plays with the cat too much, and forgets other things. I like that this is like a clear inference. Like, when you get a cat, you're going to forget to do laundry because you're so excited about playing with the cat. Effects on others. As a result, others feel nothing. I just think there's the inference is that there's nothing here. But I mean, like if person X has a partner and the partner maybe didn't agree to the cat before the cat suddenly showed up, I imagine there would be some feelings. Or if it was adopted as a surprise, which I would say don't surprise people with animals. But if like they knew that their partner wanted the cat and just like had agreed to it and they were prepared to care for it, and it was just like, oh, here's the kitty. Oh. As a result, others want, others then none. Cat receives a lot of attention from person X and no effect. So different sort of like representations of things that might happen. Some of them are, obligate, and some of them are not. Ashay says cross-domain learning. Yeah. I think that's what I'm looking for. When you have a model that's doing multiple tasks. Yeah. Oh, that sounds almost right. It sounds like 90% right, but it also doesn't feel quite right. Ugh. Oh. I don't remember. Sorry, I'm just trying to see if I can pull it out of the oatmeal again. It's not there. Oh god, there's the best paper at ACL about it that I'm pretty sure had it in the title. ACL 2017, 2018, a while ago. Anyway, It's not that important. How do we provide machines with large-scale, contextualized, common sense knowledge? The solution is to leverage manually curated common sense knowledge resources, such as ConceptNet and Atomic, to train a model that can dynamically produce such knowledge for a given context. Common sense knowledge resources are typically sparse, making training a knowledge-based completion model to extend the resource less efficient. So most of the relationships that exist in the world are not going to be represented in the knowledge base. Pre-trained, but I mean, it's better than nothing, right? I think is where I stand on that. Pre-trained language models and their inherent knowledge come in handy here. Language models such as GPT implicitly represent knowledge, so you can retrain them on completing knowledge-based assertions, e.g. from Atomic, and teach them the structure of knowledge. This is what Comet, Common Sense Transformers, does, as illustrated in Figure 18. Interesting. I would only use this resource if I knew that it had undergone extensive hand vetting. Illustration of the training process of Comet. The language model is fine-tuned to predict the tail entity, e.g. inference and Atomic, given the head entity and the relation. That was behind my head. Okay, so given a seed entity and a relation, learn to generate the target entity. The head entity, person sails across oceans, requires buying a boat. I don't think that's true. I think you could sail across the ocean in a rented boat. But it could be the case that if you had sailed across the ocean, you had bought a boat to do it. Comet is capable of dynamically generating inferences for any context. For example, if we modify the context from Atomic to David adopted his sister's cat because they found out her husband was allergic, which, for obvious reasons, does not appear in Atomic, Comet no longer predicts that person X, David, had to go to a shelter, but instead that he, for example, needed to find out about it. Okay, so this is the dynamic generation, I think, is extremely useful for, situations that have not been talked about before. And due to the infinitely generative properties of language and, the depths of human creativity and the fact that new situations occur all the time, that is really cool and interesting. Comet has been used successfully. Ajay says, not sure myself. No, it sounds like that's definitely a term, and I think that is what I'm looking for, but it just feels, I don't know. Sometimes also you find out what it was and you're like, oh, it's not satisfying. It doesn't feel right. Anyway, but thank you. I appreciate it. This is gonna bother me. It's when you get something stuck in your teeth, but for your brain. Comet has been used successfully in various downstream tasks requiring common sense knowledge. Also, because of the dynamic generation, this means that this cannot all be hand vetted, which is, It's on GPT? Did it say? It did not say. Okay. Is this one of the workshop presenters? It is one of the workshop presenters. Comet has been used successfully in various downstream tasks requiring common sense knowledge. Models trained on Atomic or on ConceptNet are available, and the demo for both Atomic and Comet can be found here. There's also a visual Comet that can generate inferences from images. Interesting. Yeah, let's see if I can get some more information in it. Alright. So this is visual Comet. I don't know why this is the one that I pulled up, because I am definitely not definitely not a computer vision person, but I thought that this might be helpful to look at. Okay, so here we have person 2. Person 2 wanted to hold on for his life, wait for help to arrive. Before, person 2 needed to find something to hold on to, swim towards the statue, sense his own death. Jiminy Cricket. After, person 2 will most likely be washed away, scream for help, keep his head above water. And then there's person one here. Before, person one needed to realize the ship was sinking, notice water rushing in, get caught in a rush of water because person one wanted to swim to safety, get to the top of the deck. After, person one will most likely sink in the water, help to get out of the water, and try to help person two. I don't know what this is a scene from, but it looks like it's from a movie, maybe? I don't know. I don't think I've seen it before. Okay, interesting. So it's reasoning about what's happened before and after, and it's out of University of Washington and AI2, which is also in Seattle. It's the Allen Institute for Artificial Intelligence, which was founded by Paul Allen of Microsoft. I think Microsoft, right? That's what Paul Allen's from. Anyway, I'm just gonna quickly check that because I think that might be the wrong thing. Yeah. He co-founded Microsoft with Bill Gates. Cloud Giant says, are there also data sets that combine the statements with probabilities and how they change our beliefs in other statements? Or is this done implicitly through modeling using symbolic data sets as inputs? Maybe, but that sounds... So I think a lot of the knowledge data sets... I have not worked with them extensively, but I think a lot of the knowledge data sets are specifically about relationships that presumably are true all or most of the time. So I don't know that they're doing a lot of work to, represent beliefs, right? Like these should be... I guess another way to think about it is common sense should be a shared belief, right? If it's not something that is generally accepted, then probably it's not very helpful as common sense, if that makes sense. Even though modeling someone's like individual mental state might be, very useful and helpful, for example, in, teaching and trying to figure out where someone's going wrong. But yeah. And Quick24 says it's short for PsyCorp. Oh, helpful. That's the CYC psych dataset. Summary. We talked about ways to acquire and represent common sense knowledge in a machine-readable format, ways to measure common sense reasoning abilities, mostly using multiple choice questions, and ways to integrate this kind of knowledge into models. None of these is solved yet. Word. I would say that that's like a good tagline for NLP. It's not solved yet. Manually collecting all the common sense knowledge is infeasible, while extracting it from text or from language models suffers from inaccuracies, reporting bias, like the Black Swan thing, and societal bias. Looking forward, a promising research direction is multimodal common sense knowledge acquisition, e.g. learning from texts along images and videos. For example, look through enough class photos, you might learn that the kids in the front row typically sit, especially when the kids in the last row are also seated. And then there's a little square around a kid in the front row of a class photo sitting. That's an odd example to pick, but I guess it's true. Machines may reach human performance on common sense benchmarks, but it's often due to being right for the wrong reasons rather than actually possessing and successfully applying common sense knowledge and reasoning abilities. Generative tasks are somewhat less prone to this issue, but we would have to develop reliable automatic evaluation metrics to make them the standard. Yeah. Quick24 says, you sound like someone who's been gifted a cat. I mean... There have been cats that showed up in my life. Yeah, like I said, I quite like cats, but not going to be in my current life, not least because I have a dog that I don't think would do well with a cat. But he's a sweetheart. Machine common sense reasoning is becoming more and more popular within NLP, so I am optimistic for future breakthroughs. So, yeah. So biggest challenges for common sense reasoning. I mean, obviously data sets and structured knowledge representations, which seem to help quite a bit and help prevent you from saying factually incorrect things, right? So that's a big thing. And Hi, Joven. I think another really big problem is this problem of multiple choice questions, right? Multiple choice questions do not tell you about reasoning very well. They can sort of get you kind of approximately there in a lossy way. But, you know, it's like, I don't know, it's like testing children, right, to understand what they say. So like for me as an educator, if I really need to understand where someone's mental state is, I will assign them essay questions. And I know no one loves essay questions, but it's much easier to see where things are going wrong in an essay question than it is in a multiple choice question. Also, like, very hard to cheat in an essay question, right? I don't know. I've had a lot of thoughts about automatic proctoring and all my education that I've been thinking about recently, but something that is relevant to this discussion that I ran across, let me see if I can pull it up real quick, because it's not, let me see if I can find it. I know I saw it on Twitter. So there is a new benchmark that's human in the loop. So if you're not familiar with the term, human in the loop means that like during model training, there is a point at which humans look at it and offer feedback. I'm pretty sure I liked it on Twitter, so I'm just scrolling through my Twitter likes now. Here we go. Yeah. I found it. So, it's actually out of Alan AI. So it is a leaderboard that was like just announced like 2 days ago, I guess, for natural language generation tasks. So a lot of the sort of approaches for common sense reasoning, you know, could very easily be applied to generation, and I think that would be, or the argument that the authors are making in this blog post, it is just read, the argument the author's making in this blog post is that will, improve our understanding of what models are doing and give us a more accurate give us a more accurate understanding of what the model's internal state is. And there is a new leaderboard that has just been launched that uses human evaluation as part of its launch thing. Wow. Anyway, human evaluation is expensive, and human in the loop is expensive, and anything where you have human labor adds expense just because it's people's time, and you should pay people for their time, and ideally pay them like sufficiently that they can live well. And because of the scale of machine learning models, that is difficult. So this is a leaderboard that specifically is for natural language generation, and that includes a human evaluation component that has been funding by the AI2 folks. So yeah, which Vered I think also is at AI2, the author of this blog post. Okay. Anyway, just an aside there that this is definitely something that the community is thinking about quite a bit, and that has gotten a lot of sort of interest, and that people are actively working on. So I definitely found this really helpful, because the last time that I checked in on like common sense stuff was 2016, I think would have been the last time that I did a lot of common sense background reading, and sort of this definitely covers the time since then, and a lot of the approaches, and a lot of the things that people are doing, and I think it's definitely interesting. I don't know, I'm a pretty big fan of structured knowledge. I think that it's a good way of representing relationships. It is, of course, expensive. Again, there's that human time costs money, as it should, component. So yeah, I think that's all my main thoughts, and it is exactly 10 right now. Yeah, very helpful blog post. If you're interested in this sort of reasoning, I recommend maybe going through and clicking through some of the other resources. perhaps obviously, I don't think it's obvious. A lot of the papers are probably going to be a little bit less readable than this sort of blog post that's designed to be a little bit more approachable. But I think this certainly has helped me update my current understanding. Also, yeah, I was completely wrong about ConceptNet. I thought it was something completely different, and I don't know what I was thinking about. Actually, let me see if I can find it really quick. I'm just doing some searching. Bunch of stuff on knowledge graph based search engines, which is not what I'm looking for. Knowledge graphs, different knowledge graphs. Well, I can't find it briefly, so I'm just going to say I don't remember and just leave it at that. That's okay, because it sounds like ConceptNet is sort of emerging as a standard. And also I imagine they could use some additional annotation help. I don't know. I don't know how you would get involved. I wonder if it's in here. Attribution, share alike. You can't change the license. That's yes. The API, lots of results compared to WordNet, compared to Google KnowledgeNet, compared to BabelNet, compared to DP Data, OpenPsych, Microsoft Concept Graph. Oh. Yeah. Oh yeah, I guess they're not doing, so it looks like they are using sort of machine learning techniques to extend it, and rather than adding new information by hand. Okay, during the golden age of crowdsourcing, ConceptNet accepted direct contributions of knowledge. That was a great start, but now the opportunities for improving ConceptNet have changed, and we are content to leave crowdsourcing to the organizations that are really good at it, like the Wikimedia Foundation. Interesting. If you contribute to Wiktionary and follow their guidelines, the information you contribute will eventually be represented in ConceptNet. Okay, so it sounds like they're not taking direct contributions anymore, but if you're interested in contributing, you can contribute to Wiktionary. All right, so I think I'm going to call it there. I really enjoyed this blog post. I remember writing down there was a paper that I wanted to do next week, but I do not remember what the paper is. Let me see if I can find it real quick just to give you all a little sneak peek. Reading group, that's what this is called, right? Oh, right. Somebody extended Rasa NLU to Vietnamese. So I thought we would read that paper because I've had a lot of questions about different ways to extend Rasa to work with different languages. And you all know that I am very salty about English being centered in all the NLP research. So we'll go through that paper, see what they did, and hopefully that'll be helpful for folks who are working in other languages as well. So that's what we'll be reading next week. Tomorrow we've got live coding. I'm going to try and get my Rasa X instance up and running and good to go. And yeah, and then we'll be back next Wednesday with more Q&A with office hours. So hope to see you then. Have a great, I was going to say weekend. It's Thursday. I guess if it's your Friday, have a great weekend. And I'll see y'all tomorrow. Have a great day, and